Welcome everybody. This is me Rameshwar Paudel. Welcome to my presentation. Today I'm gonna give a presentation on modeling the potential of intercropping in Australia. So this will be the outline of our presentation today, where we will discuss about some introduction of intercropping and the problems which motivated us for this uh, study, and we'll discuss about some project aim and objectives, and there are some research questions which we will try to answer on at the end of this research project. We'll discuss about research design and methods. We'll discuss some expected outcomes, and at last we will discuss about the conclusion. uh, First, we need to know about what intercropping is. The simultaneous cultivation of two or more crops on the same piece of land is known as intercropping, and it has drawn interest because it may improve sustainability, overall crop output, and resources use efficiency. Agricultural ecosystems are diverse because of the various forms of intercropping, including row, mix, strip, and relay intercropping, which we can also define as the types of intercropping as well. So these are the major four types of intercropping mainly used. Cereals and legumes crops can be intercropped to increase yield and preserve and reestablish soil fertility by using symbiotic nitrogen fixation by legumes. So preserving soil fertility is one of the important things these days. Mandal et al. On 2024 conducted a study in Bangladesh and discovered that intercropping maize and soybean in 1:2 ratio produce a maize equivalent yield of 5.48 ton per hectare compared to a single maize yield of 2.48 ton per hectare, which is almost more than a double of single maize yield. Gitwi et al. 2023 evaluated the APSIM model's ability to simulate intercropping effects by comparing it to observed data in three different states in Australia, as well as theoretical combinations of crop and crop densities. The different advantages and challenges of intercropping are on one side, and the rapid increase in diversity need of people due to overpopulation around the world lie on the other side. To determine the optimal intercropping mixture or combination that works well with Queensland's environmental circumstances, we adapt to apply the APSIM next generation model. So the problem. So here are some problems that motivated us for this study, which are increasing food demand due to rapid increase in population and limited resources. Sustainable intensification of agriculture is on the way to tackle the challenge. So this is very important. And the modeling concept is widely used in monocropping and not especially in intercropping systems. And most of the researches were done outside Australia, except Gitwi did it on 2023. So we'll try to implement the APSIM next generation model to identify the best intercropping mixture or combination that fits well in Queensland environmental conditions. Aims and objectives. So the main aim of this study is to analyze different intercropping options in Australia to find out the best intercropping suitable for different climatic conditions of Australia with high yield along with diverse food options. We have got some objectives as well, which are measure the potential yield of intercropping, selecting combinations that are relevant to improving yield and soil conditions, to analyze the land equivalent ratio for intercropping in Queensland, Australia. So here are some research questions that we will try to answer at the end of this project. The questions are, what are environmental conditions and agricultural practices conducive to successful intercropping in Australia? How can the APSIM model technique be used for intercropping systems for specific regional and cropping scenarios? What are the economic benefit and challenges of intercropping in Australia? And is land equivalent ratio sufficient for intercropping to prototype them in Australian conditions? Research designs and methods. So this project involved the use of AFSIM next generation modeling framework for a variety of areas around Australia. We will be creating and executing simulations that compare possibilities for temporary intercropping with traditional single crop monoculture cropping to identify the environmental circumstances in which intercropping yields a yield gain. We will examine the simulation findings. So, expected outcomes. First of all, let's hope the research will be successful in finding outputs. We may find land equivalent ratio and gross margin under intercropping. We may give alternatives to Australian farmers by analyzing location-specific intercropping options. We may find a solution for food security as well as environmental maintenance. We may find a significant advantage of intercropping than monocropping in Australia. We may attract the government along with stakeholders to watch out for the scope of intercropping. So in conclusion, the research focus on the potential of intercropping in Australia, a method that can improve resource utilization and productivity in like hot and dry climate of Australia. Intercropping can suppress pests, disease and weeds and increase organic soil carbon and nitrogen stocks. However, the increasing food demand due to population growth and limited resources necessitates sustainable intensification of agriculture. The study aims to identify the best intercropping mixture for combination suitable for Queensland environmental conditions. The project uses the APSIM Next Generation Modeling Framework to create and execute simulation comparing intercropping with traditional single crop monoculture cropping. Uh, I would like to thank University of Southern Queensland for providing us this platform for this research. Uh, Special thanks to my supervisor, Professor Keith Pemlenton, and teaching team, Dr. Chinhawi Tao and Dr. Bree Wilson for supporting us for this project. Here are some references that we have used for this research. And thank you everybody for giving your time for this presentation. If you have any questions, please let me know. We can discuss this later on. Thank you.